How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at just some general properties of phases, with our objectives being to describe the difference in behavior between solid, liquid, and gas, which is usually indicated with like parentheses S, parentheses L, and a parentheses G for whatever we're talking about. For example, if we said NaCl solid, we're saying the sodium chloride is in the solid state. We also want to be able to illustrate the phases using particle diagrams and compare the entropy of phases of matter. So let's start with that. What is entropy? Entropy is a measure of disorder in a system. It's basically, how messy is that stuff. So if we take a look, here we have a particle diagram for the solid state, where you can see it's pretty neatly organized. There's a nice pattern going on. Liquid, we have things starting to move around and get a little messier than gas. We got things all spread out and moving around in every direction. So in terms of entropy, we have low for the solid and high for the gas. So you can see the solid is very organized. It's not very messy. Whereas the gas, it's acting all crazy. All right, so gas. All right, so a lot of times we see these things that we call particle diagrams. It's basically just you got this box, and in it you draw particles. The particles are just little circles. And you go, all right, well, let me draw what a gas would look like. Well, the particles in a gas are going to be all spread out and moving around. And if you're drawing something, you can't really draw movement too much, so you just draw them spread out and taking up the whole shape and volume of the container. So for gases, particles are spread out and move in straight lines until they collide with the container or another particle. They have no definite shape or volume. So their shape will be whatever the shape of the container is. The volume that they occupy will be the entire container, right? They are what we call compressible. It means if you were to apply pressure and you were to try to force them together, they would get closer together. So if they start off kind of spread out, if you added pressure, well, what would that look like? You would be forcing them to get closer together. You can compress it. And this has what we call high entropy compared to the other phases. It's very messy. They're moving around all over the place. That's a gas. Liquids. All right, well, let's draw a particle diagram for a liquid. Draw a little box. And the liquid particles, well, liquids don't take the whole volume of the container. They'll fill it from the bottom because they're not a gas. So particles are able to flow past each other. So they're able to move around. They're not stuck in place like they are in a solid. They're able to move past each other, but they're still very close together. They have no definite shape, but they have a definite volume. So what shape will the liquid be? It'll take the shape of whatever you put it in. What will the volume of that liquid be? That will be definite. It will always have that volume. All right. So liquid particles, since they're very close together, they're what we call incompressible. If you put a bunch of pressure on them, they will not get closer together. They're already close together, but they're able to flow past each other. And they have what I'm going to call medium entropy. It's not as chaotic as a gas, but it's definitely more messy than a solid. All right, solids. Let's draw a particle diagram for a solid. All right, so solids, probably by experience that they have a definite shape, right? You put it on a countertop, it's going to keep its shape because it's a solid. The particles in a solid are arranged in a crystal lattice, which is basically just a regular repeating pattern. So you can see hey, this is the pattern I'm going with, and it's always going to be in that pattern. It's a solid. How do they move? Well, they can't flow like liquid particles, and they aren't spread out like gas particles. What they do is they vibrate in place. So they don't move in relation to each other, but they're all kind of shaken together. So they're unable to flow past each other. They have a definite shape. So definite shape. And they have a definite volume. and they are also incompressible, just like the liquids. That since compressible, there you go. Just like the liquids, since they're already right next to each other and touching each other, you can't compress them to be any closer. And this state has the lowest entropy out of the three of them. All right, so that's just a quick rundown of the properties of phases. So again, generally, I mentioned this: solid has the lowest, gas has the highest entropy, and liquid is kind of in the middle. All right, so can you summarize? Can you describe the difference in behavior between solid, liquid, and gas phases? Can you illustrate the phases using particle diagrams? And can you compare the entropy of the phases matter? That's all. Hope you found it helpful. See you in class. Okay, bye.